Okay. So as we're going through, whenever we are doing anything, what do I always want to do first? What should my first step be? If I look at this, what do I want to do first? So the first thing, whenever you see a rational expression, rational function, you want to do is you want to factor. So I'm going to just factor this. If I look at the top, is there anything I can do on the top to factor that? Yeah, I can factor out a 2x. If I do that, I'm left with x minus 2. In the denominator, I want to multiply to 8, add to negative 6. What multiplies to 8 and adds to negative 6? Negative 2 and 4. So this is x minus 2, x plus 4. Which I guess this is right here. It's having that. It's like the step 2 we're doing it, but we're just going to do it right here because I've already started it. Okay. Do I have anything that divides out? Yes. Yes, so they'd both be a negative. That's what I meant to say. Okay. Do I have anything that divides out here? Anything that's the same on top and bottom that divides to 1? That x minus 2. So this is 2x divided by x minus 4. Okay. So what is x not equal to? What are my excluded values here? Can't be a 2 or a 4. So we're going to come back and look at those when we get when we get down to like step 2. We'll use those. So when we're looking at horizontal, I'm going to say, or slant asymptotes, we want to compare the top and bottom of the fraction. We can either do it before we simplified, we can do it after we simplified. But I like to just look at, I'm going to take the highest degree on each of those. I'm going to say, let's look at that 2x and the x. I'm going to say, let's look at these two right here. If I was to take 2x and divide it by x, what does that give me? I have a 2. Do I have any x's left right here? No. So that means, well, do I have a horizontal asymptote? Yes. So this right here, we're going to have a horizontal asymptote. The degree on top and bottom was the same, which means my horizontal asymptote is y equals 2. So that means at the line y equals 2, or that's what my end behavior is going to end up. The ends are going to end up approaching that line y equals 2. Okay, so we've already factored everything up here. So I have 2 discontinuities, 2 excluded values, which means 2 discontinuities. Are either of these removable discontinuities? Yes. Which one's removable? 2. So I have x equals 2 is removable. So what feature on the graph do I have if it's removable? Is that a hole or an asymptote? We're going to have a hole. So I know we're going to have a hole at x equals 2. How do I figure out where that hole is located? What do I do to determine the location of the hole? So plug it in where? Find f of 0. So I'm going to plug 0 in. Is that what you're saying? Because you said something at 0. Or did you? Yeah, so we're going to plug the 2 in. So I'm going to plug the 2 in right here. So I plug that hole in. I'm going to say, well, what happens if I could plug 2 in? So we're plugging it into the simplified. So we can't plug it in right here, but we can plug it in right here. So if I plug in 2, I have 2 times 2 divided by 2 minus 4, which is 4 divided by negative 2 or negative 2. So that means my hole is the point 2, negative 2. So it means on my graph, there is not going to be a point at 2, -2. There'll be points that are around it, but actually 2, -2, there is no point. Okay, so x equals 2 was a whole. What does that mean x equals 4 is going to be? What do we see? What kind of discontinuity is x equals 4? So it's not removable, which means it's non-removable. So on the graph, what feature of the graph do I have if it's non-removable? So I have a vertical asymptote. So my vertical asymptote is going to be the line x equals 4. So my horizontal asymptote is y equals 2 because the degree on top and bottom was the same. So we're essentially just dividing those two and seeing what we get. For the asymptotes and holes, I am looking to see where are my discontinuities. Removable gives me my hole. Non-removable gives me my asymptote. And then for the x and y intercepts, if I want to look for the x-intercept, where do I look? How do I find that x-intercept? Anyone remember how I find an x-intercept? Okay, so we're top of the equation. What do I do to the top of the equation? Equals 0. So 2x equals 0. What does that mean x is equal to? 0. So I have the x-intercept is 0, 0. If my x-intercept is 0, 0, what do we know about the y-intercept? It's also going to be 0, 0. But if we didn't recognize that, I'm going to put 0 in for x. 2 times 0 divided by 0 minus 4 equals 0. So in this case, my x and y intercept are the exact same point. It's not always going to happen, but that's just how it worked out this time. Okay. Is there any questions so far on what we've done? Okay. So I'm going to put what we know so far on the graph. I'm going to scroll down. So we have a horizontal asymptote at y equals 2. So I'm going to draw this on here, but I'm not going to do just a solid line because the asymptote itself is not part of the graph. I'm going to put some boundary lines on here. So I'm going to say, okay, at x equals 2, my graph, at least in the end, is going to approach that line. We had a vertical asymptote at x equals 4. So I'm going to draw myself a vertical line at x equals 4. We have an x-intercept of 0 and y-intercept at 0. So I've got a point at the origin. And then I'm saying we have a hole at the point 2, -2. So this is what we know about the graph so far. Any questions about what I put on there? Okay. So when we have these asymptotes, my graph is going to end up having to approach that asymptote, the vertical asymptote. Since I can already see it's like it's going to connect there. This is going to have to approach that asymptote. So it's not going to go up and then down. It's just going to keep, it's like the asymptote is pulling the graph towards it. And then it's going to end up pulling towards the asymptote over here. So I know down here, my graph looks like that. Are there any questions about how or why I connected those that way? Okay, but I don't know what happens after x equals 4. So what I'm going to do is I'm going to just choose some point in this section that we don't know. And I am going to just plug it in for x. Just choose some x value, plug it in. What number should we plug in for x? 108. So I'm going to say, let's say, what is f of 8? So I'm going to plug 8 in for x. So I have 2 times 8 divided by 8 minus 4. And I'm plugging it into the simplified version. You could plug it into the original one, but the original one's got a lot more going on. I'm just going to go simple. So I have 16 divided by 4, which is 4. So that means that I know I'm going to have a point on my graph at, 8, 4. So I have a point right here. So really what I'm trying to figure out is what side of the asymptote is my graph on, or am I positive and negative? I'm just trying to figure out kind of where am I going to end up. I have a point up here. I'm never going to come down to the x axis again because I only have one x-intercept. So this graph is going to end up being pulled up towards the vertical asymptote, down towards the horizontal asymptote. So that is what that graph is going to look like. And we could have plugged in any other number of points, but these graphs, I know they're always going to have to approach those asymptotes. Okay. Are there any questions about this graph? And if you have them, please ask. Okay. So based on what we just did right here, I actually want you guys, if we turn over, I want you to see what you can do on example 2A. I want to see if you guys can get something for that. So it's very similar to what we just did. You can work together if you need to talk to each other about doing that. But I want you to see what you can do on example 2A. And then we'll look at that graph together after we do that. So we'll take, did I say 2A? I did 2A, yeah, so 2A. Yep. Okay, so when I'm looking at this, we want to factor the denominator. I think everyone got that factoring as x plus 4, x plus 5. So then I have x plus 5. That divides off, leaving me with 1 over x plus 4. We all good there?
Yes.
Okay. And then I know that x is not a negative 4 or a negative 5. So when I'm going and looking at my horizontal asymptote, what will the horizontal asymptote be? Which just going to be y equals 0 because the bottom is bigger than the top. As far as the degree goes, we could look at the beginning, we could look here, but your bottom is always going to have a higher degree than the top, which means it's going to be pulled, the y values are going to be pulled down towards 0 on the ends. If I want to look at the vertical asymptote, which of my excluded values is going to give me the vertical asymptote? Yeah, so we got the x plus 4 is going to do that, which means, so vertical asymptote, we're not going to just write negative 4. An asymptote is not just a number. It is an equation. So you want to write x equals negative 4 on your assignment. It's going to make you write the equation. On the quiz, it made you write the equation. If you just wrote the number, then you get it wrong. And then for the whole, what x value is my whole going to be? Negative 5. So I'm going to say, well, if I plug negative 5 in, I get 1 over negative 5 plus 4, which is negative 1. So my whole is at negative 5, negative 1. Does this have an x-intercept? No. So this, why does this not have an x-intercept?
The horizontal is the x-axis.
Yeah. So just because it's because the x-axis is the horizontal asymptote doesn't necessarily mean there's no x-intercept. So it's okay to cross a horizontal asymptote like in the middle of your graph. So it's not necessarily because of this. It's because what can the numerator never equal? So like if we want to find it, it's never equal to 0. So there is no x-intercept. Yeah. Yeah. So we have to set it equal to 0. The numerator is never 0, which means the whole thing is never 0. And then for my y-intercept, I'm going to plug 0 in for x. You can plug it into the original one. I'm going to plug it into the simplified because that's easier. So I get 1/4. So my y-intercept is at 0, 1/4. I'm going to go ahead and put everything on my graph. We've got a fourth is about right there. No x-intercept. Whole is at -5, -1. Pay attention that on here it's counting by twos. So just when you put that on the graph, it's counting by twos. Vertical asymptote, x equals -4. Horizontal asymptote is y equals 0. So your graph will typically always follow the asymptotes. So I am going to so it's going to follow the asymptote here, follow the asymptote here. And I know it's never going to cross the x-axis. So we're just making sure we don't do that. Because sometimes you'll have it where like your x-intercept will be like right here and it ends up just doing where it would follow in this case on the top of the asymptote instead of the bottom. But that right there is what that graph's going to look like. Are there any questions about that graph? Okay. Let's look at, I think I'm going to look at, we're going to look at probably just two, look at a few more of these. Let's look at, let's come down and look at C. That one looks fun. Okay. So if I look at C, this one's nice because it's already factored for you. Do we have any factors that divide off? X plus 1. So x plus 1 divides off. So I have x divided by x minus 3, x minus 1. How many vertical asymptotes is this graph going to have? We're going to have 2 vertical asymptotes. Does that mean there'll be like nothing in the middle? No. So for this, so I have x equals 3 and x equals 1. Those are my vertical asymptotes. Because we have for this x is not 3, 1, or -1. Okay. If I look for my whole, what? So the whole happens at what x value? -1. So I'm going to plug -1 in for x, which gives me -1 over -1 minus 3, -1 minus 1, which is, that's a -4, -2. It's -1 over 8. So it's at -1, -1/8. Okay. And then I'm looking for my behavioral asymptote. Which, does the numerator or the denominator have a higher degree? If I look at this, we've got an x on top. How many x's do I have multiplied on bottom? 2. So the denominator is really an x squared. So does this have a horizontal asymptote? If the bottom has a higher degree? Yes. So we do. We have a horizontal asymptote. What is my horizontal asymptote going to be if the bottom is bigger? 0. So I have a horizontal asymptote at y equals 0. Okay. When we look at so we've got vertical asymptote, whole, horizontal asymptote. Let's look at x-intercept. What number makes the top of the fraction equal 0? What number makes the numerator 0? So I set the numerator equal to 0. I get x equals 0, which means my intercept is x-intercept is 0, 0, which means the y-intercept is also, without even doing anything, I know it's 0, 0. Okay. So I'm going to put all of this on my graph. There's an intercept. My asymptotes are at 3 and 1. So this is going by 2, so we're going to just do that and that. You'll notice that my x-intercept is on my horizontal asymptote. That is totally legal to have that happen, because the horizontal asymptote is really a behavioral asymptote. It's your end behavior, what is happening there. So middle can do whatever. It's just at the ends we need to make sure that we approach that. Okay, looking at this, we know exactly what this graph looks like. We know, actually, we need to put our hole on there too. Let's put my hole on here. Got a hole at -1, 8, or -1, -1, 8. Okay, I know exactly what this graph looks like, right? Just looking at this. So I know that these points, like my hole and that intercept, are going to connect. We need to end up, like this is, I'm going to draw these points in a different color so we can actually see them. Let's do that. So my graph needs to end up approaching my asymptote. So it's going to kind of, so like it comes down and then it comes back to my asymptote. So I know that. I know. So this could potentially go back down, but how many? So we think back to our multiplicity of roots, multiplicity of our x-intercepts, multiplicity of solutions. What was, like, how many factors in my numerator gave me x equals 0? Or like this right here is just an x. It's not an x times x. So if we think about it, when we had our multiplicity of 1, when we only had the solution one time, did we cross through the x-axis or did we bounce off the x-axis? So we crossed through. So this is going to end up following this one on top and not the one on the bottom. Okay. So this is all I know about my graph so far. We don't know what's happening over here. So what I'm going to want to do is I'm going to want to find at least one point in each of these sections. So I'm going to find a point, let's say x equals 2. Or a point in there. X equals 2 is nice because it's right in the middle. So I'm going to say, let's find f of 2. I'm going to just choose a point between 1 and 3, which 2 is the only integer there. And I'm going to plug that in. When I plug it in, I have 2 divided by 2 minus 3 times 2 minus 1, which just ends up giving me a -2. Are there any questions about that? So I plug 2 in. 2 minus 3 is -1. 2 minus 1 is +1. So the denominator is just -1. 2 divided by -1 is -2. Okay. Is this graph going to cross through the x-axis in this section at all? No. Why can't it? Why am I not going to cross through the x-axis here? Yeah. The only x-intercept is right here. So what do you think my graph is going to look like in this section? Yeah, so it's just going to be, go down like that. Okay. So we've got this right here. So now I want to know what happens in this far right section. So we need at least 1 point over there. What number should we plug in for x? 6. Okay. That seems like a good number. Is that the only number you could plug in? No, just choose whatever number looks nice.
2.
I have 6 divided by 6 minus 3 times 6 minus 1, which is... Yeah, so 6 over 3 times 5. So we end up where it's 6/15. So it's like, I don't know, right? Somewhere, it's basically, we just know that it's going to be a positive number. Will I cross the x-axis in this section over here? Anywhere. So I'm never going to cross the x-axis. So my graph is going to end up doing something like this. Okay. Okay. Are there any questions about this graph? Okay. Okay, let's look at D now. Let's look at this one. So I have x squared divided by x minus 1. Does this have any holes? No. So this, does this simplify it at all? Can I simplify that? No. No. So I have x can't be a 1. So that x equals 1, is that a hole or a vertical asymptote? Vertical asymptote. So my vertical asymptote here happens at x equals 1. Okay. When I look for, so there's no holes. If I'm looking for my, like, a behavioral asymptote, does the top or bottom have a higher degree? The top. So does this have a horizontal asymptote? No. This is going to have a slant asymptote. Right. So the way that we find slant asymptotes is I'm going to do this division. So I'm going to take x squared and I'm going to divide that by x minus 1. I'm going to do this with synthetic division. So I put a 1 on the outside. Do I just put only a 1 on the inside?
No, you have to do 1, 0, 0.
1, 0, 0.
Yeah.
So I drop the 1, multiply, and add, multiply, and add. So this gives me x plus 1 over x minus 1. So lots of 1s here. So what is the equation of my slant asymptote? So is it just x plus 1? Is that the equation? Is x plus 1 an equation?
Yeah.
No. What do I, how would...
Oh, yeah, you don't do the measure, do you?
Yeah, so y equals x plus 1 is my slant asymptote. Okay. Okay. So we've got my vertical asymptote. I have a slant asymptote. We need to know the x-intercept and the y-intercept. So if I look, these ones have been kind of boring as far as x and y-intercepts go. So if I'm looking for x-intercept, I want to know what makes x squared equal 0. 0. So this is going to be 0, 0. But I'm gonna think about this. What? Okay, so it's squared, but it's just gonna be 0 is just 0. It's not positive. It's not negative. It's just 0. But with this squared, if we think about, like, this right here is really x times x. When I had two factors that gave these, that gave me the same x-intercept. What does the graph do at that point? If we think about polynomials. Yeah. So at that point, like it bounced off the x-axis. So that's going to end up happening here, where this is going to end up at that point. It's going to bounce off that axis. Okay. So x-intercept was 0, 0. My y-intercept then is just 0, 0. Okay. So there's the intercept. My vertical asymptote is x equals 1. My slant asymptote is y equals x plus 1. So this is why on your assignment last night, or like from last time, I gave you some problems where I wanted you to graph a line from slope-intercept form, because we're going to be graphing some lines in slope-intercept form. So I'm going to take this line y equals x plus 1, and I'm going to graph it. This is count like it's going by twos, so we are just going to have to do that. So I've got here is my y-intercept is 1. What is my slope of this line? 1. So I'm going to go up 1 over 1, up 1 over 1. So it's kind of just going like it never for this one ends up going on any of the corners that are drawn, which is like, anyway, so this right here, this line, instead of having a horizontal asymptote, we have this is my asymptote. That's the line that we're going to follow. Okay, you look like I have a question, Kimmy.
Why is it like right above the dot?
It's because this is counting by twos. So this right here is 1. So that's my y-intercept is 1.
It's up 1 over 1. So what is it?
So it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it never ends up being.
Oh, I see.
Yeah, it never ends up meeting the corners that are on there, just with the way this worked out. Okay. So we said that this is going to bounce off of that x-intercept because it's the multiplicity of 2. It's the x squared. If we also even just think about y equals x squared, it touches that intercept. Let me do this different color so we can see that. So this, we're going to bounce off that point, and we're going to end up going down over here. And then we're going to follow this asymptote to the left.
Oh, wow.
So that's what this is going to do. It's going to slant that way.
Wait.
And then we need to figure out what's happening up here. So I need to plug some number in for x. Figure out what's going on there.
23.
3. Okay, we can plug 3 in for x. I feel like all my work over here is just. So I'm going to say if I go f of 3 seems good. I have 3 squared divided by 3 minus 1. That's 9 over 4, which is 9 over 2. That's what I meant. I don't.
Extra credit.
So 4.5. Again, my mind, I knew we were going to get it to 4.5, and I wrote that down like a step early. So I have 3, and then 4.5 is like right here. So that means we're going to end up in this top little section right here. So it's going to do something like that. So the big things that I'm going to be looking for as far as graphing is, do you have your asymptotes correct? Do you have your intercepts correct? And then are you in the correct like regions of the graph? Like, is your behavior around the asymptotes going the correct way? Okay. How are we feeling? Do we want to look at another one? Do we want to start the homework? What do we think? And does anybody want to see another example?
No.
Is there anyone that wants? Because if anyone wants us to look at another example, we can look at another example. Is there anyone that wants to look at another example? Okay.